In a remote region of Siberia, a frozen lake became the focus of scientific attention after a series of unusual measurements were recorded beneath its surface. The lake itself is unremarkable. It has no permanent settlements nearby. It has no documented industrial activity. For decades, it attracted little interest. That changed when seismic monitoring stations began detecting repeated signals originating from beneath the lakebed. The signals were not strong enough to be classified as earthquakes. They did not resemble volcanic or tectonic activity, and they were confined to a very specific location. This video examines what has been recorded beneath this lake, what explanations have been proposed, and why none of them fully account for the data. Location and background. The lake is located in a region of continuous permafrost, where the ground remains frozen year-round, sometimes to depths exceeding several hundred meters. Permafrost in this area has been stable for thousands of years. Temperature fluctuations are minimal. Large-scale geological changes are rare. Historically, the lake has shown no unusual behavior. Satellite imagery from the early 2000s shows consistent freeze and thaw cycles, typical for this latitude. There are no known fault lines directly beneath the lake. There are no recorded volcanic systems nearby. There is no evidence of human excavation or underground construction. For this reason, early anomalies detected in the area were initially dismissed as sensor error. However, the readings persisted. Seismic data. Beginning in late 2024, seismic stations monitoring the region began registering low-frequency vibrations beneath the lake. These signals shared several unusual characteristics. They were repetitive. They originated from a fixed point. They occurred regardless of surface weather conditions. Typical seismic activity produces irregular waveforms. These signals did not. Instead, the data showed repeating patterns over extended periods of time. Geophysicists compared the waveforms to known sources, including ice cracking, underground gas movement, permafrost collapse, distant tectonic activity. None of these matched the observed data. Gas-related seismic signals usually appear in bursts. Ice cracking produces sharp, irregular spikes. Tectonic activity spreads outward across fault systems. The signals beneath the lake remain localized and consistent. According to internal notes from researchers reviewing the data, the term most frequently used to describe the signals was structured. This does not imply intention, but it does imply organization. Surface anomalies. Around the same time seismic anomalies were recorded, changes on the surface of the lake became visible. High-resolution satellite imagery showed irregular ice formations developing along the lake's surface and edges. These formations included circular depressions, linear ridges, sharp vertical ice features. In isolation, many of these features could be explained by known ice dynamics. However, their appearance over short time frames raised concerns. Some formations appeared within days. Others disappeared just as quickly. Drone surveys conducted during brief summer thaws revealed layered ice structures, suggesting repeated freeze-thaw cycles that did not align with recorded temperature data. In multiple cases, ice fractures radiated outward from central points beneath the surface. No definitive explanation has been established for these formations. Laboratory simulations attempting to reproduce similar structures under controlled conditions were unsuccessful. Biological and geological hypotheses. Several explanations have been proposed to account for the activity beneath the lake. One hypothesis involves ancient biological systems preserved within the permafrost. Permafrost is known to trap microorganisms for tens of thousands of years. Some of these organisms can remain dormant and reactivate under changing conditions. In theory, microbial activity could produce heat or gas, leading to localized seismic signals and surface deformation. However, this hypothesis does not explain the regularity of the seismic patterns, the fixed point of origin. The absence of detectable gas releases another hypothesis involves unknown geological formations beneath the lakebed. While Siberia contains complex subsurface structures, geological surveys in the region do not indicate formations capable of producing sustained, repetitive signals of this type. No magma chambers have been identified. No caverns large enough to collapse cyclically have been documented. Each explanation accounts for some aspects of the data, but not all of it. Unresolved questions so far. As of early 2026, monitoring of the lake continues. The seismic signals have not ceased. Surface anomalies continue to appear intermittently. No conclusive explanation has been accepted. There is no evidence to suggest deliberate activity. There is no confirmation of biological emergence. There is no proof of artificial structures. At the same time, the data cannot be dismissed as noise. Multiple independent instruments have recorded the same patterns. The signals persist across seasons. The anomalies remain localized to the lake. This places the phenomenon into an unresolved category. Not proven, not explained, not ignored. In conclusion, remote regions often reveal anomalies simply because they are observed less frequently. In many cases, unexplained data eventually finds an explanation through improved measurements or new models. In this case, that explanation has not yet arrived. Until it does, the lake remains an anomaly, a location where multiple independent observations point to activity beneath a frozen surface without a clear cause. Further research may resolve the mystery, or it may reveal that current models are incomplete. For now, the lake remains under observation. If new data emerges, this case may change significantly. Until then, it remains an open question. Thank you for watching.